Hello, this is David D. Hilster. I'm a critical thinker, dissident scientist, and if you are not science woke, then this is the place for you. There are literally thousands and thousands of scientists from around the world who've been working for decades outside the mainstream, who've identified problems, fixed those problems, and who are proposing new theories and models. You're not going to find anything like this at all on YouTube, so make sure you go down below, click on that subscribe button and the little bell next to it. Well, I told you I was reading this book. I just got it, actually. I've known about it for a long time. In fact, I think it was published in the 1990s, if I can see. See, here it is, in fact. And it was published when? It was published in 1998, first published by Halton Arp. But, of course, he has passed on. And it's a great read. He's one of the great dissident scientists of our time. Why? Because he's talking about seeing red. Well, what's seeing red all about? Well, it has to do with redshift. What's the redshift? Well, just like when you hear something go by real fast with an you hear that like Doppler shift. Well, they say in the 1930s they saw redshift everywhere, and they were looking around. They said, well, that must mean things are moving away. Things are shifted. They should be the regular colors, but they're shifted to the red side, which means they must be all moving away from us. Therefore, if they're all moving away from us, maybe there was a big bang. It all sort of exploded. That's where it all comes from. And seeing red, of course, is a phrase that also means in English, for those who are not native speakers, of being mad. I'm seeing red. I am mad. So I'm going to go through this book. Actually, there's no e-version of this book here. So what I did is I photographed them, put them through a scanner on my phone to try to make them look as pretty as possible. You're not going to be able to read all of them, but I will be going through and reading them. We've got quite a lot of slides because it's very interesting to see Halton Arp, one of our great scientists out there. In fact, you should check it out right there. I have another video that I just talk about Halton Arp. He is a hero warrior and a critical thinker, and he was absolutely science woke to the max. So let's go forward in the preface. So I'm going to be reading this stuff here. Again, this is photographs, trying to make them look good here for YouTube, but even with that, it's going to be a little small. My purpose in publishing this book is to communicate information which would not otherwise be accessible. Well, what does that mean? Well, that means he's publishing this book because, in fact, people are not supporting him in academia, universities, mainstream science, from what he is saying, from the conclusions of observation. He's looking through telescopes and he's observing and he's looking at data. That's what the whole book's about. About 10 years ago, my first book on this subject appeared, Quasars, Redshifts, and Controversies, which I'm also going to get. I don't have that yet. The first book had really been written between 1984 and 1985, but it took a seemingly interminable 2 years to publish because uncountable numbers of publishers turned it down. One university press that was of my alma mater, was enthusiastic about it until they gave it to a member of the astronomy faculty to read. Guess what happened? Well, you can imagine. They didn't accept it. Another Cambridge University press declined to publish it, but once it was published, bought a large number of copies at a very low cost to sell through their distribution. Well, it turns out also he says later in the book, somewhere in the book, I don't remember where, because I go hopping around in that book a lot, all books. And he said, well, it turns out that a lot of the people did buy the book because they wanted to check to see if their name wasn't in it, because they didn't want to be associated with real science, real controversy. Well, it shouldn't be controversial. You should find problems. So let's keep going here. It says, if there is any credit due for all this, I should mention that when I left the United States in 1984, I came to the Max Planck Institute for Astrophysics, first on an Alexander Humboldt Senior Scientist Award, and I then stayed as a guest scientist. I must acknowledge that if it had not been for the use of the facilities of the Institute, the hospitality, support, and friendship of researchers, I would have not been able to carry out the present work. So that's pretty amazing that he was accepted outside in Germany accepted much more outside its country than inside its country. It tells you about the politics. Here in the United States is a lot worse in a lot of ways. Why are redshifts the key to extragalactic astronomy? Well, he looks at redshift here, and it's what he's talking about. So if we look at light from another object after it has spread out from short to long wavelengths, we see peaks and valleys due to emission and absorption from its atomic elements. One thing we can measure is how much these features are displaced from the wavelengths in the laboratory standard. So when we know that stars are made out of certain elements, and we know that when we look at those elements, the wavelengths of those elements, because they do emit wavelengths, and look at the peaks and the valleys of those, we find that they're in fact shifted. So when we know it should be right here, it's shifted. Everything's shifted to the redshift, and that's what they're talking about. I won't read the details about that because we have a lot to get through. It says cosmology, because it concerns our ultimate origins and our future destinies. Most people are interested in the nature of the universe in which we live. We call this picture of our environment in its broadest possible sense cosmology. And let's see what he has to write about it. There is now a fashionable set of beliefs regarding the workings of the universe, greatly publicized as the Big Bang, which I believe is wildly incorrect. I'm not sure I have to break that down much, but it is great to look at it linguistically, because you can tell Dr. Halton Arp is not a big fan. He says fashionable set of beliefs. Here are all the words that make this sound not so, how do you say, that he believes in it. He's calling it fashionable. Fashionable is something that comes and goes. Beliefs, that's something that you believe in. You don't check to see if it's right or wrong. You go on faith and the workings of the universe. Greatly publicized. Again, he's saying publicized, meaning, hey, we're publicizing all this information as the Big Bang, which I believe is wildly incorrect. I mean, I'm not sure you could put a bigger adjective there, but he definitely does. So anyways, but in order to enable people to make their own judgments about this question, we need to examine a large number of observations. And that's what this book is all about. So you can tell where he stands as a critical thinker. Science woke. He is absolutely science woke. This is a great one. I love this. Academia. Experts in physical science now are almost exclusively trained in universities. Our society financially supports theoretical scientists and facilities primarily through the academic hierarchy. You can see there he is, again, it's already sort of negative, this whole description. So that's what he says, first couple sentences under this. So there's another reason why it is not sufficient to relate just the new factual results. The current beliefs are the crowning achievement of our research and learning institutions, and if they are so completely wrong and have been for so long in face of glaring evidence to the contrary, then we must consider whether there has been an overwhelming breakdown in our academic system. Now you can see this guy is absolutely why people outside of mainstream really admire this guy. In fact, like I said, I helped arrange getting him an award called the Cygnus Award a number of years before. Well, very close before he was dying, I think, and we gave him a Lifetime Achievement Award because he absolutely deserves it. I feel very honored to have had a little bit of part in recognizing him. That's what we need to do, folks. Okay, so here's a picture and that we're looking at, and it says right here, high radio. It says the radio galaxy Cygnus A showing ejection of high energy radio emitting material in opposite directions. So what you're going to be seeing what you see in this book are galaxies with two ejections from most of the time from the center of the galaxy, and that's what his study was all about. But that's the first picture in his book. So you can see this little dot in the middle there, and then you see these sort of two puffs there. It looks sort of like an explosion going on. But that's really one of the concentrations of the things he's looking at. And the other thing he was looking at, what he was famous for, was not only what we call peculiar galaxies, but the quasars. In 1963, some radio sources which had been identified with apparent stars were being studied spectroscopically. What were puzzling stellar spectra, however, suddenly turned out to be the emission line galaxy spectra shifted to very long wavelengths. There was some hesitation at first about accepting these redshifts as due to recession velocities that approach the speed of light. So what he's saying is that they saw these radio sources through radio telescopes, and the red shift was so great that the recession velocities, meaning recession means going away from us, was so great, it was even close to the speed of light, that they were really reluctant to even accept what that was. I mean, because it's against going the speed of light. That's going way too fast. They can't do that. And he talks about that. So that's another thing. So he's talking about galaxies, quasars, and the red shifts associated with them, which is basically when you look at the elements coming out of these objects and you compare them to the elements here on Earth, there's a shift to them, and they were also assumed to be velocity. And it turns out that there's a big problem with that. X-ray observations confirm intrinsic redshifts. Whoa, what does that all mean? Just another isolated case. He's being sarcastic. Your eye slid over the phrase because you wanted to see whether the referee was going to recommend publication. The answer was not for the astrophysical journal letters. The message behind the smooth, assured phrases was clear. No matter how conclusive the evidence, we have the power to minimize and suppress it. So it says, what is the evidence this time? Just two X-ray sources unmistakably paired across the galaxy, well known for its eruptive activity. The paper reported that the compact sources of high energy emission were both quasars, stellar appearing objects of higher redshift than the central galaxy, and he gives it the number. Obviously, they had originated from the galaxy in contradiction to all official rules. Slyly, the referee remarked that because there was no known cause for such intrinsic excessive redshifts, the author should include a brief outline of the history to explain them. So what's really important here is, let's see if I have a picture coming up, and I think I do. Here we go. Yep. So what's really important to look right here is you see that big blob in the middle, which is sort of this blob that you see in this direction right there. See, that big sort of looks like a ship on the bottom of the ocean that's sunk or something in the middle there. That's a galaxy, and you can see how those concentric rings there are right there. If you follow my finger straight across, you're going to see all those, like, it looks like a fingerprint. That's the center of the galaxy. Then you're going to see two big circles right next to it. One right here and one right here. Not this dude right there, but one right there. You can see sort of it looks like a donut, and then one there it looks like a donut. Well, what that is a picture of is very famous with Halton Arp, is that those are the quasars, and he was claiming that those are ejected from galaxies. And he even goes on to say, I believe, don't quote me, but I believe so, that those could, later on, or he had mentioned before, that those could then turn into galaxies themselves. So it's sort of like galaxy seeds, whatever. But that's not important. What's really most important to this book and what he's saying is that those are being ejected. And what he's saying is that when you look at the redshift, which was considered to be something that, the redshift considered to be something that was supposedly giving us that there was a recession or going away from us, that the thing was speeding away from us, that these two quasar, that one and the one way over on the other side, that those were traveling way too fast. Because and what they would say, well, no, Halton, you are very much mistaken. Those must be in a different place or really far away from where the galaxy was. So the galaxy had one indication of where it should be in the Big Bang, to say it in layman's terms. The other two quasars should be in a position in a totally different place because their redshift was much greater, so they should be farther away. So these things shouldn't be related, but they were. And of course, the argument was, well, we don't see it, but if you draw a line, if you can, like right there, if you draw a line right through my finger, How could that be? They're almost equally distant. You have one on one side, one on the other, and they go right through the center of the galaxy. What's the chances of that? And not only that, this isn't the only one he found. He found many others. And so when you look at the redshifts here, the intrinsic redshifts, you're seeing that what you're going to see is that, in fact, they're very similar. What he was saying, you can look at them. The two quasars had very similar redshifts, meaning, they were, and then the galaxy had its own. And what he's talking about, intrinsic redshift, means that redshift is intrinsic. It is a property of the object, not of its velocity. Goodbye, Big Bang. And that's why he was a dissident, and that's why he was a critical thinker, because he looked at the data. And he was ousted. He was literally taken away. His time, again, we're putting this story, it's really a great story, that written by Laurie Gardee, one of my favorite scientists today, and she is just a brilliant mind, and she wrote a great article for us for the Science Woke. Where's Dave when Science Woke coming up? Go to sciencewoke.org. I should put in there, I got to put a subscribe there so you can put your email on. We'll let you know when it's up and running. Okay. Intrinsic redshift and stars. Oh no! If we are to believe the previous 3 chapters, then most extragalactic objects have intrinsic redshifts, ranging from large values for high redshift quasars, continuing down to small values for low redshift galaxies. It was important to discover that the low and medium redshift galaxies also had non-velocity redshifts, because it meant that the effect pertained not only to quasars, but which could be argued to be exotic and not well understood. Now the phenomenon could be also studied in nearby galaxies. Having gas, dust, and stars could be resolved individually as components about which we thought were we knew most of what was important. We know what's important. What he's going to say here, and what he says there, right in that on that right there, intrinsic redshift in stars, is in fact all these objects, stars, galaxies, quasars, they all have intrinsic redshift. Again, redshift is a property of the star, of the galaxy, of the quasar, and it is not because of recession or velocity. Recession because you're talking about the Big Bang, because everything's supposed to be going away from us. Gravitational lenses. Okay, I'm going to skip a lot of stuff here. In his book, he goes on, most of this book, he goes on a chapter after chapter, looking at specific, right there, looking at specific, you can see the quasars, you can see the relationships, showing evidence after evidence after evidence after evidence for what he's talking about. That quasars, in fact, are linked directly to galaxies. Those quasars have a redshift that do not match the galaxy. So how could that be? They don't match what would be going on in the Big Bang. This is a huge problem. This is a big problem for big science, big physics, big cosmology, and from a big man, Halton Arp. So gravitational lenses, what is that? Well, gravity bends light. That's the idea of Einstein's general relativity. So he talks about gravitational lenses where we should see things. So it says, prior to 1956, the Swiss astronomer who had illustrations and turbulent career in California was aware that strong gravitational fields had been shown to bend light rays, as in the famous eclipse observation of displacement. Of course, that we know from Einstein. At the time, he started looking for extragalactic object, which might directly be behind another, and thus have its outer light rays bent inward by the gravitational field of the foreground objects. So he's looking for these halo, these sort of light's going to go around these big objects like galaxies, and you're going to see like a galaxy behind a galaxy, which you shouldn't see, but only because of Einstein. The more common situation to be expected was when the background object was not exactly centered in the gravitational ring, collapse into a one-sided arc. But no striking examples of that were found either. So they're looking for all these things for gravitational lensing. So the subject had gone dormant. The sudden revival of gravitational lensing to the huge industry is simply due to quasars. In the 1960s and 1970s, they started finding high-density quasars concentrated around nearby. So he was looking at quasars. What he's saying is they were trying to find evidence for gravitational lensing. Of course, if you know anything about my channel and you watch Dr. Edward Dowdy of NASA says, hey, gravity doesn't bend light. What actually bends light is mass in space, like the corona of a sun. So yeah, when they looked at the stars going through the corona of the sun in 1919 to try to confirm Einstein's hypothesis that gravity bent light, yeah, they were bent, but not because of space-time or gravity. In fact, outside the corona doesn't. So, but what he's saying, in the book he's saying here, Halton Arp, is that gravitational lens, they were trying to find it, but couldn't find it. That's not good for general relativity. We talk about it all the time. It's just like, well, we're critical thinkers. We're trying to be science woke. I'm trying to make you science woke. I'm your science therapist, remember that. So anyways, that's what he's saying. It's really ironic because what he said, I believe that's what the next one, he says, excess galaxy, it says, it was nice to be a hero, but it was only for a day. That was all right with me, though, because I thought the pairing and separations of quasars made their ejection origin from galaxies indisputably obvious. It was on, then off. It was on, then off for galaxy lensing. So basically what they looked at his work, since they want to worship and continue Einstein, said, oh, Einstein, you are so great. Light-bending galaxies. Well, gravitation or galaxies bending light should be there. And say, oh, let's go look at Halton Arp stuff, which we rejected and we took him off the telescope, but we'll use his stuff anyways. So he's saying it was nice to be here for a day. Censorship at the critical point. Phil and I wrote all the results up in the best journalese style with all the tests, numbers, and references and submitted to the Astrophysical Journal letters. The editor sent it to a referee who just written a paper on... Oh, wait a minute. Did I just read this? No. Einstein cross. No, this is not. It's not. He had been looking for the fifth image predicted by gravitational lensing theory, had not found any convincing evidence for it, but concluded anywhere that he had straightened out the interpretation as a lens. He didn't find it, but if the facts don't fit the theory, change the facts. He wrote 3 reports trying to get us to say our results were the results of chance noise, and then rejected the paper. What he's saying is that when you look at the little filaments, if you look at little different spectra of light, you can start to see that the quasars are attached by either gaseous filaments or whatever. But he says, no, that's just noise, so we're going to reject it. Anyways, I feel strongly about what happened, and I want to make my position clear. Astrophysical Journal Letters is the normal journal for publishing new observations for the Hubble telescope. The telescope costs billions of dollars of public funds. The vast majority of the page charges which pay for the publication of the journal come from preeminent supported contracts. So what he's saying is, this is all supported by money, it's all supported by what those people do, and if it doesn't fit it, you don't get in. So he's saying, this is supposed to be on its merit of what you're saying, not whether or not you support a big project, whether you're related to a big multi-million or billion-dollar Hubble telescope project. But that's what he's saying, nope. It says redshifts as a function of time. The most useful feature of the derivative solution is that it explains the preceding book full of observations. What he's saying is this book, all the observations. If particle masses are a function of time, then the younger electrons have smaller masses. This is really interesting. Now he's talking about whether this is right or wrong. He's talking about masses changing over time. It's like, whoa, wait a minute. When a less massive electron makes transition between atomic orbits, the photon involved has a lower energy and resulting spectral line is redshifted. So this is really interesting because I put this in here because even though I don't believe this is what's happening and a lot of people may not, it's important to note that he is trying to explain it and give it a mechanism. And he's not only doing that, he's not afraid to say something like, the electron's bigger. What? I mean, even for me, that's strange. But you know what I think? Seriously? Because I read this, I skimmed through this. I don't always remember everything I read, but I do pick out these parts. As when I read that just now, in my gut feeling, it says, whoa, I got to look into that. And that's what you need to do if you have your own theory. You can't sit there and just say, well, my model shows that's different. No, be careful. Someone like Halton Arp could be right and you could be wrong. So always keep your mind open to those things. Is the universe expanding? So what do you think he's going to say? Any guesses? If you put it down below. No, I'm kidding. I'm just not a real big fan of put it down below. Unless, of course, you really have a really good question. Most people would immediately claim that the redshift apparent magnitude relation for galaxies proved the universe was expanding. But distances to galaxies are large, and the light takes an appreciable time to travel to us. So we see the galaxies as they were when the light left them. That is younger. It turns out that for the galaxies created at the same time, but seen at different distances, solutions require that galaxies which are seen at younger stages to have exactly the same redshifts as observed in the Hubble relation. In fact, the slope of the relation, and he talks about it, the observed Hubble constant is predicted within an error of measurement of only one number by age of galaxy. The fact that there is no effect left over the to be interpreted as distant velocity relations means the universe is not expanding. Put it in a nutshell, what he's saying is the calculations that we see with redshift and or what we see as redshift, why it's happened, that it's intrinsic, it's not having to do with all those things. Even when you measure where we know the galaxies are, etc., he says a distance velocity relation means the universe is not expanding. The result is supported by all the previous evidence that most of the extragalactic redshifts are intrinsic and not velocity. Summary of the Big Bang versus continual creation. What? Wait a minute. Okay, so he finds out in his book, and he's got mountains of evidence, and you can read this. I got this for like $6 delivered to my door, so you may want to find these. They are out there. Libraries would say, "Who wants this stuff? This stuff's been proven wrong." Get them now, because then you can give them to your future generations, and they can sell for lots of money because they'll be worth a lot. Anyways, summary versus Big Bang. Summary of Big Bang versus continual creation. So what he's saying is, maybe there's not a Big Bang. Things are just being created and living and dying cycles. That's what he's saying here. So I'm not even going to read this part, but that's what he says. He talks about, in fact. He's talking about a chart here, but most important is I wanted you to see that title. So he's already arguing there. So he takes what he knows, which is redshift is intrinsic, it has nothing to do with velocity, and if that's so, what does that mean for the rest of science? And he spends a good part of the book, in the back of the book, on that. So even if you get the book and you don't want to read through every part of every peculiar galaxy and quasar, and peculiar in a good way, that's what they call them. Look them up, peculiar galaxies. You can see Halton Arp in Wikipedia. And Wikipedia is true. Big science as the medieval church. This is far from the first time this parallel has been noted. The church, still in Galileo's time, was the ultimate authority on the most important matters. The church hierarchy was handsomely supported by princes and working people, and the lifestyle of the cardinals depending on having people believe that their pronouncements were important and profound. Due to a complex of political, economic, and internal events, the church gradually lost power to those who protested. And after the ideals of the Enlightenment and the heady rise of astronomy and physics, however, we have the present-day situation where the authority of natural law has been passed to science. We have in return for importance and profound pronouncements on the nature of the universe, the academics are supported with high salaries, expensive facilities, travel, prestige, and a lifetime of security. I read that wrong, but I just corrected my English bad reading. There also bestow the power of this institution onto its successors. So he's just saying basically it's all shifted from the church to science, and that it's really not a scientific endeavor. It's much more akin to religion, where you're told what the truth is. Again, this is not a knock on religion at all. Well, you know what it is? It's a knock on religion, because religion has a much purer and better philosophy. It doesn't claim to be the facts of the workings of the universe. It has a different claim, and in the claims of big science, big physics, and big cosmology are lying to you. So in my opinion, it's worse than the religious dogma that sometimes people talk about. But again, we're talking about science here, not religion. The most compelling piece of evidence, of course, is the Mid-Atlantic Ridge. Now, here's another part. On the title here, imagine right here, right here. No, whatever. Plate tectonics, right there. So he's talking about plate tectonics. So what does he think about plate tectonics? He's a critical thinker. He's going to accept, the regular plane. The most compelling piece of evidence, of course, is the Mid-Atlantic Ridge running from the far north to the far south between Euro-Africa and American continents. That seam has been measured to be opening up a few centimeters per year and spilling material from the interior onto the surface. This is just about the rate during which an order of magnitude of the age of the Earth, to account for the distance appeared between the continental plates and their breakup about 250 million years ago. This would be interpreted by a number of people, meaning the Earth is expanding in size and pulling the continents apart. So, Halton Arp actually, before it was really popular, talks about expanding Earth. Doesn't mean what he's talking about is how this has worked, but he is noting that. And what does he say about it? This has been interpreted by a number of people. A notable proponent has been a geologist from the University of Tasmania, S. Warren Carey, who was alive at the time when he wrote this book. Oh no, a little after it, but when he was writing his book. Yeah, around that time he died, but he was still alive while he was a contemporary of his. But it was best to consult the papers contributed to the Olympic Conference at the Frontiers of Fundamental Physics. And so what does he say about this? Anyways, going back. What he's saying is that, in fact, he goes on further, and I thought I had clipped that, but I didn't. There's another part that goes with this. I apologize, I'm not sure. It's on the same page. But basically it says, I guess then there's a debate that should be going on between plate tectonics and the expanding or expansion tectonics. He didn't call it that, but he said that, and he put it in a way. But I think, I'm paraphrasing, but I think that'll probably be squashed as well. They're going to squash any debate between those two. How amazing. So again, there he goes. Critical thinker. He goes beyond what he's even looking at in the book and says, we have problems all over the place. Okay, so this is the last part of his book before he has a glossary and all those kinds of things. But I thought I'd at least do this for Halton. This is his last paragraph. Quite interesting how he has this very specific thing, but he talks about it, about his title of his book. It says, not recognizing key observational evidence, such as that around this certain galaxy, is partially a consequence of suppressing observations like those in another galaxy paper referred to earlier. Again, those are specific evidence he was talking about in the book. All this led to public statements such as early claims of disproof of redshift distance assumptions have been subsequently supported. Early claims of disproof of redshift distance assumptions have not been subsequently supported. That's a double negative. Again, what he's saying there, early claims of disproof have been disproved, if you want to put it in early. So early claims of disproof as redshift as a function of distance have been subsequently have not been subsequently supported. They're just are not supported. So that's the phrasing that he got. You know what I mean? It's like, boy, they're bad writers. Unfortunately, it is clear by now that this will certainly continue until enough people start seeing red. And that's what this is all about. That's what this channel is all about. The seeing red, if you can get it, it's especially if you like astronomy, get it. It's worth it, just even if you don't read the real 90% of it, which is about the specific things. He's talking about a lot about the politics, a lot about what he sees in the future. It's interesting, some of the things he says, how he agrees. It's a great picture of a great mind who was taken away from a telescope, the largest telescope at the time, the 200-inch telescope at Palomar. Oh, I'm terrible with words. And he was ousted because he was saying, I'm looking at evidence, and the evidence shows there's no Big Bang. And this is just great. So remember, don't take my word for it. Don't even take Halton Arp's word for it. Get the book, read it, look at this, go back to this video, let it roll around, take a look at the evidence, and make your own conclusions. But I think if you do, the most important thing is that we all become critical thinkers and never get married to anything. Like I said, even things in Halton Arp's book, I think we've gone beyond that. But that's not the point. The point is to stay critical, stay thinking. I'm David D. Hilster. I'm your science therapist, trying to get you to your promised land of becoming science woke. Ciao for now, folks.